Hello everyone, we've graphed standard form, now let's graph vertex form. I want to use a standard form problem to kind of help us talk about some of these things, so I'm going to do this one using standard form. That's ax squared plus bx plus c. That's what we just did, but first, to find the vertex, you need to find the axis of symmetry. So remember the formula for that is the opposite of b over 2a. So the opposite of negative 6 is positive 6, and 2 times 1 is 2. So the axis of symmetry is x equals 3. Let's draw that. 1, 2, 3. That's the middle. All right. Now we know the x-coordinate of the vertex because the vertex is on the axis of symmetry. Now we need to find the y-coordinate. So to do that, I will use a calculator to help me. We're going to plug in 3. So 3 squared minus 6 times 3 plus 5. And I get negative 4. So the vertex is 3, negative 4. That's 1, 2, 3, 4. It's right here. All right, we got that. Now to find the y-intercept, you plug in 0. In standard form, you can just look at it. Because if you plug in 0, that goes away, that goes away. It's 5. 0, 5. But that's not always true. 0, 5 is right here. 1, 2, 3, 4, 5. What I mean is, when you get to vertex form, you can't just look at the last term. And I'll show you that in a second. And the last thing, find the x-intercepts. We're going to have to solve this thing. So let's see. What multiplies to 5 and adds to negative 6? It'd be, no, I need to do negative 5 and negative 1. That's tricky. X minus 5, x minus 1. So that means the intercepts are at 5 and 1. 1 and 1, 2, 3, 4, 5, which that's good because they're a reflection of each other. So 1, 0 and 5, 0. So you're going to have to solve. Here we solve by factoring. And now I will go ahead and draw my parabola as best I can. Okay. So we have the axis of symmetry that runs down the middle. We have the vertex. We have x-intercepts where it hits the x-axis. We have a y-intercept, and then we have its reflection. We're going to see all those same things in vertex form, but we need to know another way that our quadratics might look. So this is a times x minus h squared plus k. Where, what's the vertex? I'll tell you what, let's graph it in Desmos and play around with it. So here's a times x minus a squared plus k. First of all, a does the same thing it did before. When it's positive, it opens up. When it's negative, it opens down. And the bigger a is, the more narrow the graph will be. So if it's, it doesn't matter if it's up or down, 10 and negative 10 have the same width. One just opens up, one opens down. And you can see how it gets wider as it gets smaller. So a is the same. Okay, great. What's h do? 2.6, negative 3.6. Oh, h moves it left and right. That's the x-coordinate of the vertex. And k moves it up and down. That's the y-coordinate of the vertex. Notice how k is not the y-intercept, though. See how that's negative 4.6? The y-intercept is not negative 4.6. So in vertex form, you cannot just look at k and tell me the y-intercept. You have to do a little bit of work for that. And we'll talk about that in a second. But right now, let's say what we know. We know that hk is the vertex and x equals h. That's always the axis of symmetry. So the line that runs down the middle, you can just look at it. The axis of symmetry is right there. There is one trick to this. The formula has a minus sign in it. So if it says x minus negative 2, we'll write that as x plus 2, but the x-coordinate is negative 2. Okay, that's the tricky part. So here we go. X minus h, that's 2. It's supposed to be a minus sign, so the axis of symmetry is x equals positive 2. And going back to this, if I make h2, notice how this is x minus 2. So that's why this is to the right. Okay. So I'll draw the axis of symmetry first. There we go. There's the middle. To find the vertex, we don't need to do that. We got 2, negative 5. Okay, right there, the y-coordinate is negative 5. So negative 5, 1, 2, 3, 4, 5. You just look at it. You don't have to flip the sign for that one because it's not supposed to be minus sign. See how here it's plus k? That's why you don't need to worry about the sign flip. So it went right 2, down 5. The vertex went right 2, down 5. Here we are. The y-intercept, to find the y-intercept, you have to plug in 0 for x. You can't just look at it. So you have to use probably a calculator. Where's my calculator? Okay, there we go. So I'm going to plug in 0 for x. The opposite of 0 minus 2 squared minus 5 is negative 9. So 0, negative 9, which is down here. And then I will reflect that right there. Wait a minute. X-intercepts, this thing opens down. It's negative. It opens down. So there are no x-intercepts. But if I was asked to find them, I would have to set y equal to 0. Let's see if we can figure out why there are no x-intercepts. Add 5 to both sides. Divide both sides by negative 1 because you have that negative sign. Negative 5 equals x minus 2 squared. Why are there no x-intercepts? Because x minus 2 is plus or minus imaginary radical 5. Nope, those are not real zeros. So we don't have any x-intercepts. We'll just say none because it opens away from the x-axis. Let's try another one. The vertex, you can just see it. It's x minus h. But again, it's supposed to be a minus sign. So what did they plug in there to get 4? They must have plugged in negative 4. The y-coordinate is negative 1. That tells you the axis of symmetry is negative 4. Draw it. 1, 2, 3, 4. Okay. All right. To find the y-intercept, I'm going to plug in 0. So 2 times 0 plus 4 squared minus 1. 16 times 2 is 32. 32 minus 1 is 31. So the y-intercept is way up there. I'm not going to be able to draw that. 0, 31. The x-intercepts, to find the x-intercepts, you set y equal to 0. 0 equals 2 times x plus 4 squared minus 1. And now we solve like we did on the quiz. Add 1. Divide by 2. Square root both sides. Now that's plus or minus 1/2. The square root of 1/2 equals x plus 4. So now to get x by itself, negative 4 plus or minus radical 1/2. And if you're going to graph it, you probably do need the decimal versions of those. So I'm going to type them in. Negative 4 plus the square root of 1/2. And negative 4 minus the square root of 1/2. We'll just change it to a minus sign. So negative 3.3 and negative 4.7. Negative 3.3 and negative 4.70. Negative 3.31, 2, that's about here. Negative 4.7 is about there. They're both really close. So I got to put the vertex on here. That's negative 4, negative 1. I can't fit the y-intercept on this grid, so I'm just going to go ahead and draw what I've got like that. But if you get this, which is from the solving, you're going to need to get them as decimals so you actually can see them on the x-axis. But there are 2 real solutions there. All right, so we're going to practice vertex form quite a bit. We're going to practice standard form quite a bit. So make sure you guys have gone through those, check your delta maths, and smash that like button.